Open source is modifiable. So far, we've learned from the OSD that open source is for everyone and provided in human-readable source code as well as machine-readable object code. The third point of the OSD requires that it is modifiable too. That's the open source definition, in case you forgot. Ooh, look at me. I'm picking this OSD stuff up so fast. In the first course, and so far in this course, we used MakeCode blocks as the human-readable code in our code lessons. The blocks make a great introduction to coding. Maybe in the future, we will see more code like this in people's day-to-day lives. We'll use block code around our homes and in people's jobs, even if they don't know much about code. Are you ready for a challenge? In order to do more powerful things with computers, we're going to need to develop our use of languages. You too can be a developer, and as you improve your skills, you will need to develop your use of coding languages. Software is written in languages, just like a foreign language. Instead of German, Spanish, or French, we have Perl, Python, Ruby, and JavaScript. When we use a coding language, it's a bit harder than using blocks. We have to type human-readable words, but it's easy to make mistakes, so we get a bit of help from a tool on our devices called an editor. Editors are used to help us write that code. Some even have autocomplete systems and generate suggestions as we write. Of all of these possible programming languages, Python is one of the world's most popular coding languages due to the fact that it's both powerful and easy to learn due to its similarity to English. In fact, in 2015, a survey showed that Python was more popular than French as a language to learn in primary school. By the end of this Tempo Glove lesson, you will understand the importance of a modifiable code in open source. Modify a program which uses the set tempo block. Meet Python as a programming language, and modify a Python program to control the microbit. Today, we're going to introduce programming to microbit with Python. Tempo Glove is all about speeding up and slowing down music made with the Mini Moo Glove. We will use two melodies which play by either tilting left or by tilting right, a little like Lesson 2. To change the tempo, we can tilt the glove backwards and forwards. Tilting it backwards will increase the tempo, and tilting it forwards will decrease the tempo. So, if we wanted to play a slow version of Melody 1, we'd tilt the glove forwards, then tilt our hand left. Today's lesson is going to run a little differently. We're going to give you the hex files, which you can simply load in the MakeCode and Python editors, and we'll compare the two sets of code. Then, we'll get you playing around with modifying the code, just like a real open source developer modifying code. It's often much easier and time-saving to build on top of what someone else has already made, sort of like building an extension onto a pre-existing house or redecorating a room. We'll start by loading the hex file. Click on this link to download both hex files to your computer and head to the MakeCode editor. In the MakeCode editor, instead of creating a new project, go ahead and click the Import button and then the Import File button. Locate the Lesson 3 MakeCode.hex file you just downloaded. If all goes well, you should be able to see the following program loaded into the MakeCode editor. Let's go through the code. There are no new technical skills in this piece of code, so hopefully nothing here should be too scary. Our code has three main parts: the onStart block, the forever block, and the change tempo function. The onStart block plays 3 notes to let you know the program has started. The forever block continuously monitors whether your hand is tilted left or right. If it is, it plays a melody. either ascending notes if tilted right or descending notes if tilted left. The change tempo function is what we use to change the speed of our melodies. We do this by using the set tempo block. The higher the tempo, the faster the melody is played. In our code, we set tempo equal to 120, which is a pretty normal speed tempo, plus the rotation pitch block. Remember from lesson 1, we used a rotation roll block. Well, the rotation pitch block is like its sister. It measures how much the microbit is tilted forwards and backwards. You might be wondering why we haven't got an if-else statement to deal with tilting forwards and tilting backwards. Well, if the microbit is tilted backwards, rotation, pitch, has a positive value. If it's tilted forwards, rotation, pitch, has a negative value. Some maths here. What happens when we add a positive value and a positive value? That's right, they simply add. Now, what happens when we add a negative value to a positive value? The negative value is subtracted from the positive value. For example, 1 plus 3 is 4, but 5 plus minus 3 is 2. So, by tilting forwards, we're adding our negative value for the rotation, pitch, to the tempo. So the tempo is actually decreasing. Funny, huh? Take a break to try modifying the melodies. See how much quicker that is to modify code than having to build it from the beginning. When you're ready, come join us back here and we'll move on to the second part, where we'll be programming the microbit using Python. Welcome back. Now, if you've never used Python before, not to worry. We'll be creating a really similar program to what we just made in the MakeCode editor, but in Python. The aim in this lesson is to just introduce you to what Python looks like. We're going to want you to head to https://python.microbit.org/v/2. The editor should look like this. Time to try loading in our code. Go ahead and click the button at the top of the screen called Load Save. You've two options here. You can either drag the file lesson3python.hex into the box, or you can press the link to browse for a file and locate the hex file from your computer. If all goes well, you should see this. OK, let's go code. Let's start off with a very important concept. Importing modules. What on earth does that mean? You know, in the MakeCode editor, we have the tabs to the side called Basic and Maths and Music, etc. Well, it's like that. We can import specific modules to do certain jobs. If I wanted to use tricky maths in my code, like square rooting or something, I would import the Maths module. It's good practice to do this at the top of your Python code. It keeps your program nice and neat and makes it easier for someone else to read and understand how your program works. This is important if we're planning on making our code open source and for others to use. We can think of it like having all our ingredients ready before we start cooking. No rushing around trying to find our icing while our cake burns in the oven. Taking a look at the code, we can see we've imported the music module. But what does the next line mean? From microbit import star means that we're importing everything from microbit. The star means everything. Don't worry too much about what this means for now. Just know it's a very important line of code. One of many reasons people like Python is because it's super easy to create new variables in Python. It's just the variable name plus an equal sign plus the value. On line 6, we've created a new variable called tempo and given it the value of 120. You might recognise tempo from our MakeCode program. Then on the next line, we set the tempo of our music equal to the value of the tempo variable, i.e. 120. It's good to keep tempo as a variable instead of just directly editing the tempo in this line. By making tempo a variable, we can use it throughout our program. If we want to change the value of tempo, we only have to change it in one place, rather than searching all over our code to find all the numbers we need to change. Next, we create our two melodies. What you're seeing there, the square brackets, indicates a list. Everything inside the lists are items. Finally, we've got a while loop. This loop looks a bit odd, doesn't it? While true. What does that mean? Well, it's how we create forever loops in Python. We can imagine this block of code just like our forever block in the make code editor. The next lines look quite long and tricky, but they're going to be simple really. What they're doing is checking if the accelerometer is tilted left or right. If it's tilted left, the microbit plays tune 1. If it's tilted right, then the microbit plays tune 2. And if the microbit is not tilted, then it won't output anything at all. It uses an if-else statement, just like our MakeCode program. It's the exact same as what we created in MakeCode. It might not look like it, but this Python code is actually shorter than the code using the MakeCode editor. This goes to show just how powerful Python can be. You can do so much in just a few lines. In the next lesson, we'll be showing you how Python can be used to make the microbit do things that MakeCode can't. Ooh, I can't wait. Open source is all about modifying code. Go on, be brave. Try changing the value of tempo in the code. You could try 300 for a fast melody, or 50 for a super slow melody. If you're feeling confident, you could even try playing around with the melodies. See if you can create your own. You can download and run this Python code just like you would with MakeCode. Head to Load, Save, and this time press the button that says Download Project Hex. Drag the downloaded hex file onto your microbit and have a play around. Actually, Python has nothing to do with snakes. Its name comes from the cult British TV comedy series Monty Python's Flying Circus. This was on TV in the 1970s, and your parents might think it's cool. In 2015, a survey showed that Python was more popular than French as a language to learn in primary school. Python is an open source language and is a bit like English, so one of the easiest programming languages to learn. Being open source means that the code that the language is built on complies with the OSD and has an OSI approved open source license. That's Open Source Initiative, if you remember. So many TLAs. Although what Python, the language, does is nothing like Linux, the operating system kernel, Python has a community who contribute to the Python codebase too, and, like Linux, has its own foundation, the Python Software Foundation. That's a home where all the code for the Python language is managed by its volunteers. Funnily enough, the developer, Guido van Rossum, created it in December 1989, around the time that Linus Torvalds created Linux. So Python is almost the same age as Linux, just over 30 years old. Lots of big companies work with Python, including our friends at NASA, who are writing a really great column in the e-zine. Also, many companies you may know, like Google, Spotify, and Walt Disney too. Many of your friends will be taught Python at school, but lots of people miss out on the important point that it's open source. Being able to modify and reuse the Python code is required for it to be open source, but funnily enough, this is also something that helps to improve sustainability. When we reuse or recycle something, it's part of what's called circularity. A bit like recycling something. We reuse and modify code to make it do what we want it to. When you next find out a friend is using Python, you can challenge them. Ask them why Python is called Python. Oh, and see if they know what makes it open source. In this lesson, you have learned about the role of modifiable code in open source, to modify a program which uses the set tempo block, about Python as a programming language, and to modify a Python program to control the microbit.